Hello everyone, welcome back to A-Star Express. I am Srivatsa and I'm here to walk you through the paper 6 from the October-November 2024 series for chemistry. Alright, so moving on to question number 1. Right, a teacher uses the apparatus shown in figure 1.1 to pass an electric current through molten mercury bromide at a temperature of 300 degrees Celsius. Alright, and you can just skim through all of this right here and move on to the A part. Draw an arrow on figure 1.1 to show where the apparatus should be heated. So this is a very common type of question, and usually when they ask it, you just look at the substance in question, right? you know in the question they talk about mercury bromide. You just see where mercury bromide is, and it is over here. So this is where the heating should happen. Most of the time it's gonna be in one of the test tubes, and if you look at this other test tube, you see that there isn't anything here that would need heating. But whereas mercury bromide, you need to maintain it at a temperature of 300 degrees Celsius. So they themselves will tell you what needs to be maintained at a certain temperature, and you can use that to think about where you should be heating it. That's part A. Now moving on to part B. Name the item of apparatus labeled A in figure 1.1. Alright, again, figure A. Okay, so this is a standard question. It just tests your understanding. I mean, sorry, whether you know what the apparatus is. Let's see. So whenever heating is involved in any way in any part of the apparatus, you want to call it a boiling tube, right? Not a test tube. I mean, they may accept test tube in the marking scheme, but then again, it depends. And boiling tube is the safer bet. And part C, name the process shown in figure 1.1 which breaks down mercury bromide. So just taking another look at the apparatus, we see this power supply here. And then this is like a rule of thumb that you can have. If an experiment involves a battery, right, for this exam, it is always electrolysis, right? We do not have any other experiments that involve batteries in this exam. Electrolysis, and that'd be 3 marks here. I'm now moving on to the next part here. The electrodes used in the process shown in figure 1.1 are made from platinum. Give 2 reasons why platinum is a suitable material for the electrodes. Right, so questions like these are quite common even in paper 4, right? They ask why platinum. And then this is a standard answer, right? You can just memorize this. This isn't like specific to this question. It is the fact that, platinum is inert. And another thing is platinum conducts electricity, right? Just remember these two. It doesn't matter which electrolysis you're asking about. This is what you need to write. And on figure 1.1, draw an X to show where mercury will collect. Right, so this tests your knowledge of how electrolysis works, right? So for molten mercury bromide, the product in a way is this mercury on one side and bromine on the other side. Since bromine is a gas, it would escape out into boiling tube A. So for mercury it really needs to be down here in this test tube. It doesn't matter under which electrode you draw it. You just need to draw an X over here in the left hand test tube. All right, and now the last question. Explain why ice is used in the experiment. Right, you go back here, you see that ice is being used here, and as I said before, in this boiling tube, bromine will be collected, right? Mercury will stay here, and bromine is gonna come through this tube here and be collected over here. But that will be in the form of a gas, and you can't really contain a gas in that way. You need bromine as a liquid, which is why this ice is used to lower the temperature, and is used to lower the temperature and condense the bromine gas. All right. All right, so moving on to the second question, right? It will always be one of these where they ask about a titration or some kind of reaction. and there are multiple experiments that you need to know. So this is a lot of information, and what I'd suggest you do is just like skim through it at first, right? Just look at what's involved first, right? They want to look at the reaction between aqueous iron nitrate and aqueous sodium thiosulfate, right? And they do 5 experiments, and this is the apparatus here. And from this, you may have seen this before in past papers, right? This is really like a situation where they are measuring the rate of the reaction by looking at how fast it is able to obscure a printed piece of paper, right? So just like skim through this again. 50 centimeter measuring cylinder into a 100 centimeter beaker. So this time start a stopwatch to the current of the beaker. Yeah, when the text on the printed sheet becomes visible, stop the stopwatch and record the time in seconds to the nearest whole number. And rinse the beaker with distilled water. Right, so this is a case where, we are looking at when the printed sheet becomes visible, right, not obscure. When it becomes visible, that means the reaction is over and we can stop the stopwatch. And yeah, that's how the rate of reaction is being measured. And they're also doing this with 10 centimeters, 7 centimeters, 6, and 5 as well. That is the experiment. So this will usually be the first question where they ask you to note this down. Right, experiment 1, volume of aqueous thiosulfate, it is 15. No, sorry, yeah, it's 15, 10, 7, 6, and 5. That's what you need to be writing down. Right, and ensure that you follow the same number of significant figures that they've given here in the question. It needs to be 15.0, 10.0, 7.0, 6.0, and 5.0, right? You just have to copy it from the question. That's all we need to do. And the times as well. Now inside is minutes, outside is seconds, and if we see here 15, this would be 20. And looking at the number of intervals here, it would be about 21, 22, 23, 24 here. Okay, and same goes here as well. We have 45 over here, so it will be 46, 47, 48, 49, 50, and it will be 51. Right, just like look at whether it's a 1 scale or 2 scale. Usually it's 1 scale, and here it is increasing by a minute and 1, 2, 3. So a minute and 3 seconds. So that would be 63 seconds. Or always write it in seconds because they're asking for it in seconds. Do not include a minute term over here. And again, would be a minute and 38 seconds. So that's 98 seconds. And this would be like this is like what 2 seconds from 120, so it's 118 seconds here. All right, moving on to the B part. They just want to write a suitable scale on the y-axis and plot the results from experiments 1 to 5 on this figure right here, and draw a smooth curve of best fit. So you go back here and you see the range. It goes from like 24 to 118. So you can just round to the nearest tenths and go, okay, so it would be 20 to 120. And if you look at it here, right, what do you have the space to write? You can go 0, 20, 40, 60, 80, 100, and 120. So you can consider one interval to be 2, right? One of these intervals would be 2 seconds, and you can do this. And like the marking scheme won't exactly require this. You can go for something else as well, but the requirement would be that it reaches up to at least half of the scale. And with 120, we will be using the entire scale here, so it won't be a problem as long as you mark it properly. So unfortunately, since I am on my computer, I will not be able to mark it properly. I have been having some technical issues, but you just have to match the x and y axis and you would be good, right? So if you have 15 and 24, you look at the middle here, that would be 15, and 22, 24, right? You mark 1 point over here. Same goes for 10 and 51. 10, you go, this would be 50, right? It's in the middle. 10, 50, and this would be 52. So you have to look at the middle of these two for 51, and so on. And you should just draw a smooth curve. It doesn't exactly have to go through all the points, but like if you are skipping some points, ensure that like you have the same number of points above and below the line, right? And that should be good enough for that, right? If you have like any other questions about how you should approach that, just feel free to ask me down in the comments. And C, state why the contents of the beaker are stirred after adding the aqueous sodium thiosulfate to the aqueous iron nitrate. Right, so stirring, this is actually quite simple, right? It is simply to mix the reactants and ensure that the concentration is uniform throughout the mixture. Right, quite simple, right? This is a standard question for whenever they ask about stirring. Although if it's about dissolving, it should be about like you should talk about speeding up the process of the dissolution. But if it's about a reaction, it is about mixing them together and ensuring that the concentrations are uniform. Deduce which experiment has the highest rate of reaction. Right, so the time taken is inversely proportional to the rate of reaction, right? That's a foundational concept, so it is experiment 1. If we are talking about yield or something, then it will be directly proportional. Now use your graph in figure 2.2 to predict the time taken for the text to become visible if the volume of aqueous sodium thiosulfate is 12.5 centimeter cube. So what you should do here is what you should do here is you should have had that smooth curve, which I was not able to draw here, and just draw a line from 12.5 here. Okay, 12.5. So these are scales of 2. So 12.5 would be somewhere here, close to here. Okay, you just draw a line from here until it hits wherever your smooth curve is. Mark it over there. And then once it hits the smooth curve, you just go horizontally, right? And depending on what kind of smooth curve you draw, you would have gotten a slightly different answer. But don't worry, there will be a range of suitable answers in the marking scheme. And you do not forget the unit to be seconds, right? You need to add an S here for seconds, yeah. So F1, explain why it would be an improvement to measure the volumes of aqueous iron nitrate in a burette rather than in a measuring cylinder. So again, the standard concept that you should remember, right? Burette is more accurate than a measuring cylinder. Just remember this. And look at this. They are asking about a volumetric pipette. Again, these two questions, 90% of the time you will be getting these two questions, right? First of all, you need to remember that a burette is more accurate than a measuring cylinder. Sometimes instead of asking this, they may ask you how you can improve the accuracy of the experiment. And in that case as well, you should be saying use a burette. And then they'll ask you why not a pipette. And recall that a pipette can only measure a fixed volume, right? So you should say that the volume is not the same in each experiment, right? So only if the volume is the same in each experiment, you can use a pipette. Otherwise, you can only use a burette to increase the accuracy. Remember that if they ask for a way to increase the accuracy as well, instead of just giving this to you. Describe how the reliability of this investigation can be checked. Right, it is always repeat the experiment, right? That's something. Experiment, compare the results and exclude anomalies. Anomalies, right? And check the shape of the curve as well, right? And they'll ask you this for literally every single one of these second questions. You should just say repeat the experiment, compare the results and exclude anomalies, and check the shape of the curve. Okay, you can also write this as points, and they will expect all of this for that 1 mark. So just keep that in mind. Right, describe how the results of the experiments would change if the experiments are repeated using a narrower and taller beaker. Okay, a narrower and a taller beaker. So this would mean that the surface area will decrease, right? And it would be greater depth, so the experiment will take longer to happen. So we can say that time for reaction would be longer, and the explanation is that the depth of the liquid is greater. Right, so just remember, a greater surface area leads to a greater rate of reaction. If they're increasing the depth, that means the reaction would be slower and the time would be longer. And one more thing, describe additional measurements that must be taken to determine whether the reaction in this investigation is exothermic or endothermic. So again, this is quite a common type of question. It's measure the temperature of the container before and after the reaction. And yeah, that's that. So you can see that most of these questions are really general, right? They just, there are like a couple of specific questions like C and G, but most of these questions is just stuff that if you keep doing these past papers, if you keep looking at these past questions, you should be able to almost memorize them and just give the straight answer that they're expecting. All right, so moving on to the third question. This usually deals with the tests on the solids, and you will have these notes for qualitative analysis at the end of the paper as well, so you can use them. So let's go through it one by one. Right, we have solid M. You do a flame test on solid M, and it is a lilac flame color. So that is, you go down to the flame test, that's lilac, which would be potassium. So it's just remember that the potassium ion is a part of it. Don't make any conclusions, don't assume it's the sole ion or anything. Just remember that it's a part of it. So dissolve the rest of solid M in water to form solution M and divide solution into 4 portions. First portion of solution M, add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. So what exactly is this then? Aqueous silver nitrate, that would be this test for anion, and since it is a cream precipitate, that means bromide is a part of the solution as well, so keep that in mind. And you add aqueous sodium hydroxide dropwise and then in excess, and a green precipitate forms. The precipitate remains when excess aqueous sodium hydroxide is added. So you go to the aqueous cations here. We see the green precipitate, you see green precipitate for 2 of these. This is soluble in excess. This is insoluble in excess, and if it is remaining, that means it needs to be insoluble, so it's iron as well, that's part of it. And we add 1 centimeter cube of aqueous sodium hydroxide and aluminum foil. This is a test for an anion, specifically the nitrate, and ammonia would be produced here. And if you look at the test for ammonia, it turns dampened litmus paper blue, but look at the result here. The litmus paper remains red, so there is no nitrate. And test 5, to the 4th portion of solution M, add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. Just go back and identify what it is once again. And you see that it is indeed sulfate, dilute nitric acid and barium nitrate, and the result is a white precipitate. And we see that a white precipitate does form according to the observation. So the conclusion is that this contains iron, potassium, bromide, and sulfate. But first, the question is, explain why a yellow Bunsen burner film is not suitable for a flame test. So this is a very common question. You can just say that the yellow flame masks the color caused by the metal ion. And actually another answer that you can give, this answer is fine, it will get you the 1 mark, but you can also say that the yellow flame is not hot enough. And yeah, so either one of these would be enough for the 1 mark. And identify the 4 ions in solid M. We've already done this. you can just write iron and ensure that you write the oxidation state as well. Iron 2, potassium, right? And if the oxidation state is just 1, you don't need to write it. I mean, really, if there is only one possible oxidation state, you don't need to write it. This would be bromide. And keep in mind, you can write the chemical formulas as well. And sulfate. Right, there we go. This would be the 4 ions, and you will get 4 marks for this. Right, so now for solid N, they've given us what it is, and they just want us to find the observations. The student transfers approximately half of solid N to a boiling tube and adds about 10 centimeter cube of dilute sulfuric acid to the boiling tube. Any gas that is produced is tested. What are the observations? So they are boiling it, they are reacting it with sulfuric acid, and it's a carbonate. And as you know, when you react an acid with a carbonate, carbon dioxide is produced. So you can just write effervescence. You can also write bubbling, but effervescence is the more apt term when carbon dioxide is involved. Effervescence. And the observation for carbon dioxide, right? Again, very common question. Lime water turns milky. Okay, so the remaining parts of solid N is formed into a solution. So 2 centimeter cube of aqueous sodium hydroxide and gently warms the mixture. Any gas that is produced is tested. All right, so adding sodium hydroxide and warming it. Right, so this is a situation, I believe it is this one right here, because for aqueous cations, there isn't anything with, heating. So this is what it is, but it's not, there is no nitrate here, but there is a direct ammonium ion. So in this case as well, if you add aqueous sodium hydroxide, the ammonium is displaced and ammonia gas is released. So you should write that the observation is damp red litmus paper turns blue. So see, this isn't something that you can find out directly from this test. You just remember that, ammonia can also be displaced. It is a displacement reaction. And ammonia can be displaced, and the gas that is released will react with will change the color of the litmus paper. And you add excess aqueous ammonia, right? So since here, ammonium itself is the cation, there won't really be any change, right? You have this here, and so yeah, no change. Okay, now on to question 4, which is the plan and investigation question. So oftentimes what they do is they give you a question like this where you aren't really familiar with this specific experiment, right? Obviously we have not learned, you would not have learned about, limes and lemons and everything, in the experiment. But if you look deeper, they're actually masking a simple experiment that you have already learned beneath the surface. So if you just read the question, limes and lemons are citrus fruits which contains aqueous citric acid. So, the fact that it is citric acid does not matter, right? Just treat it as a normal acid. Don't confuse yourself with additional information. Citric acid reacts with alkalis such as aqueous sodium hydroxide. Plan an investigation to find which of the lime juice and lemon juice contains the most concentrated aqueous citric acid. Assume that citric acid is the only acid present in the juices. So, if you just think about this, they want to see which is more concentrated, and they've given you a hint that it reacts with alkalis. So this reaction between an acid and an alkali, where you are trying to find the concentration of one of these, liquids, is a titration question, right? Titration is the process that is used. We have seen this type of question, with other chemicals, without them directly mentioning some real-world application. So you just have to connect this real-world application that they mentioned in the planned investigation question to that foundational concept that you have already learned. So now, really all you need to do is, write the process for a titration, but in terms of this lime juice and lemon juice and sodium hydroxide. And so you just need to be really detailed, and I will tell you to use points for this, right, to ensure that you don't get confused, and so that the examiner can follow your points as well. So it is, so you need to mention like the volumes as well. You can't just say, take a known volume or anything. You need to mention the volume. You can say take 25 centimeter cube of lime juice in a conical flask, right? And in the exact same vein, you want to also say, just be real detailed, of lemon juice in another conical flask. Okay, and then you would need an indicator. So I'll go with thymolphthalene. Add thymolphthalene. What about that? Ensure you spell it right. Indicator to the juice. Okay, and add NaOH from a burette to a juice. Remember, if you are trying to find, since you want to know how much, well, really you can do it either way. You can either add NaOH from the burette to the juice, or you can add the juice from the burette to the NaOH, right? Since both of them are technically of unknown concentration and you aren't really quantifying it, you can do it either way. I'm just choosing to do it this way. Right, both of them will be accepted, but both methods will be accepted. Now it's swirl the conical flask until indicator changes color from colorless to blue, right? So in acid it is colorless, and in an alkali it is blue. So just mention that. Okay, and finally, so how do you make the conclusion? The juice that needs more NaOH before color change is the most concentrated. All right, so for 6 marks, this is actually all you need, right? We have 6 specific points, and yeah, this should give you the whole 6 marks here, right? You don't have to write it as a paragraph. You don't have to write it like you're doing a research project or a lab entry. You just need 6 specific points that clearly outline what you're going to do. Alright guys, so that is it for me in this video. I hope you found this paper walkthrough helpful. Don't forget to like, share, and subscribe, and good luck for your ATP exam.